Hi, my name is AMIERRA NADIRAH binti SHAHRIL and my matrix number is 293354 and I will talk about model and dataset. The purpose of the model is to provide an efficient and accurate solution for the automated classification of email, especially targeting the identification of spam. And the objective of our project is to create and automatically classify emails, which can automatically analyze the features of incoming emails and classify them as either spam or non-spam. Next is email filtering, which helps users only see relevant and legitimate message in their inbox. Next is user experience improvement by minimizing the exposures to spam, and lastly is the resource efficiency. Dataset. The dataset consists of 58 total features, and the input features that includes about 48 words frequency features, 6 character frequency features, and 3 capital run length statistic features. The target variable is class, which is binary, indicating whether an instance is spam, which is 1, or not, which is 0. The record count of the data contains about 4,602 data of row or instance for the classes. Problem and model. The problem is to be solved using this dataset is email spam classification. The primary goal is to develop a machine learning model that can be automatically analyze features extracted from the emails and accurately classify them into two categories, which is spam or non-spam. The dataset provides information on words frequencies, character frequencies, and capital run length statistics, which can be leveraged to train a model for effective spam detection. In our assignment, we use a decision tree, which is a classification method, and also the simplest way compared to others methods. This is because our context in the dataset has a binary outcome whose objective is to classify emails into two categories, spam for class 1 or non-spam for class 0, which each instance is assigned one or two possible outcomes.
Assalamualaikum and hi. My name is FATHANAH binti ZAINUDDin. My matric number is 292120. Now, I will explain about machine learning. A machine learning algorithm is a set of instruction or rule that computer program follow to learn pattern from the data. In the context of machine learning algorithm, I use to enable computer to make prediction, decision, or uncover pattern without being explicitly programmed for the specific task. The goal is for algorithm to learn from the data and improve its performance over time. Machine learning algorithm can also categorize based on their specific application, such as natural language processing, computer vision, and recommendation system. Machine learning algorithm can be categorized into three main types. The first one is supervised, the second one is unsupervised, and the third one is reinforcement. Okay, for this assignment, we choose supervised learning as machine learning algorithm. Supervised learning algorithm are designed to learn from label training data, where the input data is paired with a corresponding output label, and the goal is for algorithm to learn a mapping between input features and the correct output and able to make prediction on new data. Here the supervised learning characteristic. The first one is label training data. Supervised learning required a label dataset for training. Each example in the training data consists of input features and the corresponding correct output. Our target is whether the email is spam or not spam. Next is predictive modeling. The primary objective is to build a prediction model that can generate from the training data to make accurate prediction on new or unseen data. The third one is application. Supervised learning algorithm are widely used in various domains, including finance, healthcare, marketing, and more. Application include credit scoring, image recognition, fraud detection, and personalized recommendation. The last type of The last is type of supervised learning algorithm. We have two type, which is regression algorithm. Regression algorithm to predict a continuous output. For example, predict house price. The second is classification algorithm. Classification algorithm is a type of supervised learning algorithm that is designed in categorize or classify input data into predefined classes or categories. The goal is to learn a mapping from input features to a target class label based on label training data. Now, I will explain about the strengths. The first one is accuracy. When provided with sufficient high quality label data, supervised learning algorithm can achieve high level of accuracy in making prediction. The second one is versatility. Supervised learning can be applied to a wide range of tasks, including image recognition, speech recognition, natural language processing. The third one is interpretability. Some algorithms like decision tree and linear regression offer interpretability, making it easier to understand the factor influencing prediction. Okay, here we have three challenges. The first one is data quality. The performance of supervised learning model heavily depends on the quality and representativeness of the label training data. The second one is overfitting. There is a risk of overfitting where the model memorizes the training data instead of generalizing. Technique like regularization can help mitigate overfitting. The third one is dimensionality. Performance may degrade when dealing with high dimensional data, and feature selection or dimensionality reduction technique can be necessary. Here is example of supervised learning algorithm. Linear regression, logistic regression, decision tree, support vector machine, and neural network. For this assignment, we choose to use decision tree. Decision tree is a supervised machine learning algorithm that is used for both classification and regression tasks. The basic idea behind a decision tree is to recursively split the data into subsets based on the most significant features and create a tree-like structure. Now, to discuss how a machine learning algorithm aligns with specific requirements, it's essential to consider the characteristic of the algorithm and the nature of the problem and dataset. The decision tree algorithm aligns well with the requirement of interpretability, handling nonlinear relationship, versatility in handling different type of data, robustness of imbalancing dataset, and the ability to avoid overfitting with proper tuning. However, considerations such as potential overfitting and scalability should be addressed based on the specific characteristic and size of the dataset. I think that's all from me. Thank you.
Greetings and Assalamualaikum. My name is Mohamad Ikram bin Mohsin, mystery number 281036, and I'm here to present my findings on the model development and evaluation for our Spambase dataset. So this section will involve a lot of coding samples. So I will directly show the coding, and we will be performing the model development and evaluation based on the Spambase dataset as detailed here. So we have something 40 something rows, and then of around 4,000 instances with class as the target value. That class is a binary value ranging from only consisting of either 0 or 1. So the first we have to load the dataset into the model using a pandas library, and then separate the features and target variable. So drop the class column. And then for the purposes of this assignment, we have split the ratios into the given sections. So test ratios for 10%, 20%, 30%, 40%, 50%, 60%, 7, 8, and 9 respectively. And then this part is for just for the overall evaluation. And then, so as stated previously, the model that we have chosen is the decision tree model. And then we train the model and then make predictions on the test set. And then we evaluate the model based on these four metrics: accuracy, precision, recall, and F1 score. And then the other parts of this coding is just because we will do training on multiple types of fold, 9 types of folds, I think. So it will store in array and then print in adequate value. So in order, I want to explain about the significance of the confusion matrix and the four chosen metrics of accuracy, precision, recall, and F1 score. So accuracy, precision, recall, and F1 measure are commonly used metrics for evaluating the performance of classification models. Each metric provides a different perspective on how well a model is performing and how they are useful in various contexts. So from the confusion matrix, we have the true positive, true negative, false positive, and false negatives. And then we apply certain formula, we will get the four metrics. For example, the significance, the accuracy. So accuracy is a measure of how often the model makes correct predictions overall. And the formula is true positives plus the true negatives divided by the total number of instances. And then precision is the true positives divided by the sum of true positives plus the false positives. This is for the because precision focuses on the accuracy of positive predictions. And then we have recall, which is true positives divided by the sum of true positives plus false negatives. This is because recall measures the ability of the model to capture all positive instances. And then the F1 score, which is the balance of precision and recall, with the formula being precision times recall divided by precision plus recall. This is because to strike a balance between precision and recall, so we get the score so that it is not influenced by bias. So these four metrics derived from the confusion matrix for each model are important in order to for us to judge the performance of the model. So this is just the confusion matrix for each iteration, each split ratio. I did this 5 times so we could get the average, but the important results are down here. Okay, so split ratio 0.1, meaning the 10% testing set. Yes, 10% testing, so 90% training set. So the average accuracy of 92%. Well, for now we will just be focusing on the accuracy because the values are quite similar, all the four values. So 0.1 have accuracy of 0.92%, then 0.2 has 91%, 0.3 89, 0.4 90, 0.5 89, 0.6 90%, 0.7 88%, split 0.8 87%, and 0.9 85%. So based on as I mentioned earlier, we have this coding that just iterates and then finds the best model. So based on all of these performances, the best performing split ratio, and this is based on the F1 score because this is the most balanced metric, is decided to be 0.1, so meaning the 90-10 fold. As you can see here, the 0.1 or the 90-10 fold has average accuracy of 92%, precision of 95, average recall of 85%, and average F1 score of 90%. These results show that this split ratio with conjunction with the decision tree model has displayed the best result. So this model configuration should be applied in order to get the best results of this for this dataset of spam-based classification. So in conclusion, if we want to correctly we have shown a possible implementation of how to classify if a given web link is spam or not, using a decision tree model with a split ratio of 90-10 training and testing. So that's all from me. Thank you.